All right. Our next thing we're going to be dealing with is solving inequalities. And an algebraic inequality is really similar to an equation, except instead of an equal sign, we have one of these inequality symbols, right? We have the less than symbol. We have the greater than symbol. We have the less than, and then when there's a line under it, it also means it could be equal to, less than or equal to, and this means greater than or equal to. So a solution to the inequality, rather than just having one answer for x, a solution to the inequality is any number that would make that statement true. Okay? So for example, and we do that by doing a graph, and I'll show you what that looks like. So for example, if we have x is greater than or less than -1, basically an answer shows that of what that could equal. Okay, so we would give a little number line here. Okay, just several numbers around it. One number on each side is fine. Okay, we're going to circle where it's set up so it says it has to be -1. So what numbers would be greater than -1? Well, it'd be any numbers this way. Anything that way of anything this way of -1 would be greater than. Because it also is allowed to equal, we're going to fill it in. Okay, so a filled in circle indicates equal to. A hollow circle indicates either just a greater than or less than situation. So in this case, x can equal or be greater than -1, so that's why we fill it in, and it includes that, or you're filled in, and it's going to go that way. All right. So here we just solve like we normally would, except we have to graph it at the end. And so we're just going to divide by 3, inverse operation, divide by 3. You're going to be left with d instead of equals is greater than 4, right? 12 divided by 3 is 4. So again, we're going to kind of make a little mini number line with 4, 3, and 5. Okay, since it's not equal to, it's going to be a hollow circle. Now, in order for, oops, and I did that wrong, didn't I? 5 would be that way on a number line, because you'd have 2, and you'd have 1, you'd have 0, right? So anything, in order for d to be greater than 4, it has to be any number that way on the number line. So that's how we would graph that. Just a little arrow, a very simple graph. Okay. All right. The only time this is different beyond the graphing is this scenario. Not when adding or subtracting, only when multiplying or dividing both sides by a negative. So if when you're doing your inverse operations, if it's multiplying or dividing by a negative, you have to switch the inequality sign. And this would be an example of that. So we have to divide both sides by -3. Divide both sides by -3. So that means we need to switch the sign. We switched it. And of course we need to graph our answer. We have 8, we have 9, we have 7. So n is greater than or equal to 8. Okay? So we fill it in because it's equal to. If it's going to be greater than 8, it's got to be any number that way. All right. So negative 1/2 x. So the inverse, remember, dividing by fractions is like multiplying by the reciprocal. So we need to multiply both sides by 2/1. It's going to cancel those out, and we're going to be left with x. Multiply this side by negative 2/1. Since we're multiplying, again, we need to change the sign. We're going to get negative 10. Okay, so remember now it's negative 10, so we have negative 9, we have negative 11, right? Equal to indicates we're going to be filling it in, and if it's greater than, it's going to be that way. Notice greater than is always going to the right. No matter if it's negative, positive, greater than is always to the right. Now, I put this one in here because to solve this, we need to divide both sides by 6. Okay. Now, we did not divide both, even though negative 18 is negative, we did not divide a negative number by both sides. 6 is positive, so A is going to stay, or this sign is going to stay the same. And of course, we graph. These are all greater than. I guess I did that on accident. Okay, greater than. Notice how the greater than sign, this is almost like an arrow pointing that way, right? So that kind of helps you to remember what sign the arrow goes, because if it's a less than sign, right, then the arrow is going to be pointing to the left. So maybe that helps you a little bit. All right, these next couple, so again, dividing fractions is multiplying by the inverse, which is 3/2. Gets that to cancel out. And 3/2. Could do reduce ahead of time, and we're left with 12 on this side. Now we do have a less than sign, right? So we have 12, we have 13, and we got 11, right? Just do a little mini number line on both sides. It has an equal to sign, so it's going to be filled in. And remember, that sign is kind of pointing to the left, so your arrow is going to go to the left because it's less than. Less than is left. This one, two-step problem, we do the same thing. Add 18 first, deal with the addition or subtraction first. Now we're left with negative x greater than, or I'm sorry, it's less than 20. Okay? X is not by itself. In order to get x by itself, this is really like negative 1x. So we need to divide both sides by negative 1, divide both sides by negative 1. So now, since we divided by a negative number, we have to switch the sign. Switch the sign. And we do our graph, of course. And it's greater than, it's not equal to, so we leave it empty, and there we go.